Hello everyone, welcome to the pillars, and this is the 7th lecture of differential equation. In the last class I told you about the second order linear non-homogeneous ordinary differential equations and how to find out the solutions for different kind of RHS, that is function of x. So let me just revise all those things. So the general form of this second order linear non-homogeneous ordinary differential equation was a2 d square y by dx square plus a1 dy by dx plus a naught y is equal to r of x. So I have taken different kind of r of x like cosine or sine function or exponential function or nth order polynomial I have taken, and I told you how to find out the solution of the differential equation. That means both complementary function and particular integral. For complementary function, you know, you have to just take this d square y by dx square as m square. Similarly, this one m, this one only the coefficient, right? And then you have to find out the roots of that auxiliary equation, and depending upon that roots, you have to find out the solutions or complementary function. And for particular integral, you have to use this operator method I told you. So here we take d by dx as capital D, and d square by dx square becomes capital D square, right? And then we take this function of d to RHS and write it down as y particular integral is equal to 1 by f of d into r of x. Yp is equal to 1 by f of d r of x. And for different r of x, I have told you how to proceed in the problem. Now let's take some more form of this rx. So the fourth one, I have told you three type of rx. So the fourth one, let's say this r of x is equal to exponential function e to the power ax into h of x. And here remember, this h of x is either cos alpha x plus beta or sin alpha x plus beta or nth order polynomial. So for these cases, we will apply the below formula. I will tell you. So here this h of x must be either in the form of cos alpha x plus beta or sin alpha x plus beta, or must be nth order polynomial, right? So how to proceed in this problem? Just let me tell you. Here the same form you will get. You have to write down a2 d square plus a1d plus a naught into y is equal to rx, and yp is equal to 1 by f of the rx. The same form will be there, and here you will write yp of x is equal to 1 by f of capital D e to the power ax, and here h of x. Anything can be written. Now what you have to do, you have to put d is equal to d plus a. Whatever a is there, you have to put d plus a. Now putting d plus a, you can write down yp of x is equal to eax. You will take this eax into this side to this side, so it will be 1 by f of d plus a into h of x, right? So the first step is to take d plus a in place of a and write down the modified function of d, right? And after that the steps will be same. Like for cos alpha x plus beta, we take d square is equal to minus alpha square. For sin alpha x plus beta, we take d square as minus alpha square. And for nth order polynomial, I have told you you have to just take the lowest order d in this term as common, and after that you have to express this f of d as nth order term. In terms of d, you have to convert this infinite series. Okay, so then operate on hx. That was the method I have told you in the previous class. So the same method will be there after that, right? And let me write down here. Depending on h of x, you will use next method. For example, you can watch my previous class. For this e to the power ax will be there because this part is done. For e to the power ax, you have taken d plus a in place of d. We will do an example, you will get the better idea about it. So for example, if this h of x is, let's say, sine alpha x plus beta, then how you proceed here? You have to put d square is equal to minus alpha square. I have told you in the previous class how to proceed whenever there is a sine or cosine function, or there is nth order polynomial. So I have told you in the previous class. You can go and watch this class, right? So this is the basic idea. So let me take an example here. Example. So the example is d square y by dx square minus 2 into dy by dx plus 4x is equal to e to the power x cos x. So you can see here, this is a second order linear non-homogeneous order differential equation. Here this r of x is e to the power x into cos x. So this is in the form e to the power ax into h of x, and here h of x is cos x. So let me find the complementary function first. Don't forget to find out the complementary function because that is also part of the solution. So for that you have to take this term as 0 and write down here m square minus 2m plus 4 is equal to 0. So you just convert this to some take common and something do in here. So if you don't divide it, you can't convert it. So simply use this method. M is equal to minus b plus or minus b square under root b square minus 4ac by 2a. So here minus b is 2 plus or minus under root, here will be 4, 2 square minus 4ac. Here a is 1, c is 4. So this will be 16. So here you can write down 2 into a, here 2. Right? So here, so this can be written as 2 gets cancelled. So this will be 1 plus or minus. Here root over 12 will be there. So if you convert it, so it will be 2 into root 3, and here is 2. So this will be I into root 3. The complementary function ycf can be written as e to the power alpha x, e to the power x into c1 cos beta x root 3x plus c2 sin root 3x. Right? So this is the complementary function. And for particular integral, you can write down yp is equal to, here this is d square minus 2d plus 4. I'm sorry, this one is y. This is a typo. Okay, so you can write down 1 by d square minus 2d plus 4 into e to the power x cos x. And I told you that here the e to the power ax is there, so you have to just convert this d into d plus a. Here a is equal to 1, so you have to put d plus 1 in place of d. So then this becomes e to the power x. After putting this will be on this side, 1 by d plus 1 whole square minus 2 into d plus 1 plus 4 into cos x. Right? So you can just simplify all these things. By simplifying, we can write down this will be d square plus 2d plus 1 minus 2d minus 2 plus 4. So 2d will be cancelled, and here minus 2 is there, plus 4 is there. So this will be plus 2 and a plus 1 here, plus 3. So finally you will get yp of x is equal to e to the power x 1 by d square plus 3 into cos x. And in this cos term, you can see alpha is 1 and beta is 0. So then you can simply follow the methods I told you for cos alpha x plus beta. For cos alpha x plus beta, you have to put this capital D square as minus alpha square. Here alpha is equal to 1. That's why put d square is equal to minus 1. Right? And by putting, you will get ypx will be equal to e to the power x 1 by 2 cos x. So particular integral will be equal to e to the power x cos x divided by 2. And the final solution will be y is equal to e to the power x here, after that c1 cos root 3x plus c2 sin root 3x plus e to the power x cos x divided by 2. This is the final solution, that is the addition of complementary function and a particular integral. Right? So this is the fourth case, and here is an example. Let's go to the fifth case. What is this fifth case? We have done this, we have taken this Rx as exponential function, as sinusoidal function, that is sine or cosine function, and nth order polynomial we have taken. After that, we took the multiplication of exponential function with either a sinusoidal function or nth order polynomial. Now we will take the last case, which is the kind of functions of x which is not this kind of four types of functions. Okay, so here let me take fifth one. In this case, r of x is a function of x, any function of x which is not one of the previous type. Types. So we have done four types of r of x in the RHS. One is exponential, one is sinusoidal, one is nth order polynomial, and recently I told you the multiplication of two functions, right? So all other functions will be in this category. So what you have to do in this case, let me write down. So here you have this yp of x is equal to 1 by f of d into r of x. So here we will use partial fraction method. How? Let's see. So the general form of this f of d will be 1 by a2 d square plus a1d plus a0 into r of x. Right? So if you take a a naught common here. Let's take a naught common here. So this will be, let's take a2 common here. A2 common here. This will be d square plus a1 divided by a2d plus a naught by a2 into rx. So here what we have to do, we have to convert this 1 by this one into partial fraction. If you don't remember this partial fraction, let me tell you. Let's say after solving this, you will get, let me write down here, 1 by a2 into d minus m1, let's say, and d minus m2 into r of x. Let's say by simplifying this, you get this one. So after that, what you have to do, I'm just making you recollect all those things. Partial fraction, you have already done these things. I'm just revising it. 1 by d minus m1 into d minus m2. You take it as a by d minus m1 plus b by d minus m2. You take this like this, and after that you find out the a and b value, right? After, let's say, just for example, I am taking a is equal to 1, b is equal to 2. So after putting this one, what you will get, this will be 1 by d minus m1 into d minus m2 will be equal to 1 by d minus m1 plus 2 by d minus m2. You will find out this, right? So after that, you have to operate this individual term on Rx. So this ypx is equal to 1 by, here there is a2 d minus m1 into Rx plus 1 by a2 d minus m2 operated on R of x. Now there must be a question in your mind, if there is only 1 by d, after operating this 1 by d on Rx, we can simply integrate this R of x with respect to x. If there is d in the numerator, we can simply differentiate it. How we can operate this d minus m1 term on Rx? So there is a formula for that. That is, let's say I am taking for general case. So the formula is 1 by d minus a. Here I am not taking m1 or m2. I am just taking it for general case for any a. Operating on R of x, this will give you e to the power ax integral over R of x e to the power minus ax dx. Right? This is the generalized formula. To operate 1 by d minus a term on R of x, you have to use this formula. So this has been proved, not we are just taking it. This has been proved. If you want, you can tell me in the comment section. I will explain this to you. It will take some time, like 15 minutes, around 15 minutes it will take time. All the methods we are using, there is all those things have been derived. Not like this, we are taking all those things just recklessly. Right? So if you want to know this thing, you can just tell me in the comment section. I will explain all these things. So this is the formula you have to use. Right? So let's take an example based on this. Things will be more clear. Okay. So the example is, now let me see the example. Yeah. So the example is d square y by dx square plus y is equal to sec x. If you see, sec x, we have not done any type of r of x in which this sec x is there, or we can convert this sec x into one of those things, right? So what you have to do, we have to use this particular method. Now first of all, find out the complementary function. Like in all cases, this will be m square plus 1 is equal to 0, and here m will be plus or minus I, right? So the function, complementary function, we can write down c1 e to the power ix plus c2 e to the power minus ix, right? Now for particular integral, you can write down, as I said, yp is equal to 1 by d square plus 1 into sec x. Now I told you to convert this into the product of two terms. So if you convert this, I am doing this thing for you. You can do for all the methods, all the type of this denominator. So this will be, you have to take a by d plus I plus b by d minus I, because this will give you d square plus 1. That thing we have to do, right? Now let's take this right hand side. It will be ad minus ai plus bd plus bi divided by d square plus 1. So if you equate the coefficients, here a plus b will be 0 because there is no d term here, and minus ai plus bi is equal to 1. So let me equate the coefficients of a different kind of d terms. If you take the term d, then this will be a plus b. So a plus b is equal to 0 because there is no d term on the left hand side. Here from this you can get b is equal to minus a, or a is equal to minus b, anything. Then you get minus ai plus bi is equal to 1. If you simplify this thing, then you will get bi is equal to 1 plus ai, then divide I, we will get b is equal to a minus I, because 1 by I will be there. If you multiply I on both on numerator or denominator, this will be minus I, right? So put this b here. This will be a plus a minus I is equal to 0. That implies a will be I divided by 2 and b will be minus I divided by 2. So you can write down this term 1 by d square plus 1 as a is I by 2, I by 2 d plus I minus I by 2 d minus I, right? So now we have to operate in these individual terms on sec x or r of x, right? So let's take this first term. Okay, let me write down this yp here. This will be equal to I by 2 d plus I into r of x minus I by 2 d minus I r of x. Let's keep this thing and remove all these things. Right. So okay. So let's take the first term here. The first term is I by 2 into d plus I sec x. Here r of x is sec x. So by taking this, you have to operate this 1 by d plus I on this one. So by applying that formula I wrote here, this will be equal to I by 2 e to the power ix, because there was e to the power ax, here a is plus I, so it will be e to the power ix, right? And the integral of sec x into e to the power minus ix dx, right? And then this e to the power minus ix will be cos x minus I sin x. Let's write it down, this term as it is, and here sec x into cos x minus I sin x dx. Let me remove this part because this part is very clear. Right. So just multiply and it will be I e to the power ix by 2, integral of sec x and cos x, it will be 1 minus I tan x, because sec x is 1 by cos x and the sin x is the numerator, this will be, and after that you just integrate it, this will be e to the power ix into I divided by 2 and x minus I log sec x. I think this integration is clear because the differentiation of log sec x is first 1 by sec x into tan x. So sec x and sec x will be cancelled, only tan x will be there. So this is for the first term, right? And for the second term, there will be minus I here. Only one difference is there, minus I. You can simply put here minus I, but here plus I, and this will be everything will be same. Let me just do it here. No, sorry. Let me do it again. 1 by I by 2 into d minus I into sec x, right? And this will be 1 by 2 e to the power minus ix integral of sec x e to the power ix dx is equal to I by 2 e to the power minus ix integral of sec x into cos x plus I sin x into dx. After that I by 2 e to the power ix integral of 1 plus I tan x. So nothing much difference is there, only sign change is there. Here minus I in place of I and here positive sign. This is the only difference. E to the power minus ix into x plus I log sec x. So this is for the 2 part. And finally we can write down yp is equal to I by 2 will be common. I by 2 will be common. And after that we can write down e to the power ix into x minus I log sec x minus, because there was a minus term in between, e to the power minus ix x plus I log sec x. This is the particular integral. And earlier we have found this complementary function. You can just write down all the things, right? So I think this part is clear. Yeah, so this part is clear. So let's stop here. And one more thing, I have written, I think in the complementary function I have written c1 e to the power ix plus c2 e to the power minus ix. So you can write down that also, because by converting this that one, if you write down e to the power ix as cos x plus sin I sin x, then the same term will be there, like c1 cos x, sin term will be cancelled, and you will find this complementary function is nothing much difference there, cos x plus c2 sin x. So this one will be there. So you can write down this one or that one. So nothing much difference is there. So better to follow what I have taught you. Okay, so let's stop here. We will see in the next class, and from next class I think there is Cauchy Euler equation, second order differential equation. We will cover that part and see how far we can go. Okay, so that's it. Stay home, stay safe. Bye bye. See you in the next lecture.